Lesson 1.4 is over domain and range. This is a big lesson for us because domain and range is something that is going to follow you all year in this class, and it's a very critical piece of Algebra 2, and if you don't get it, you will, it's going to keep coming up, and so you're going to continue to struggle with it. And so I think it's important for us to give domain and range its full attention so that we can nail it down now so that we don't have to worry as much later. Okay, so let's talk about what domain and range are. Domain represents all of the possible, x values. All of the possible x values for a system or a function, okay? In order to determine what the domain is, a trick is to take your pencil vertically, like up and down, and scan the graph from left to right. So like on your paper, if this was my paper, I would literally take my pencil and scan it from left to right and look and see what is the graph doing. When does it start? When does it end? So scanning the pencil from left to right will and identify which the x values which you are touching the graph, okay? Same thing for the range. However, the range is the y values. The range is the y values. And for the range with y values, instead of scanning from left to right, you're going to scan from the bottom to the top of your graph and identify the x values in which you are touching the graph, okay? So domain is x values, you scan from left to right. Range is y values, you scan from bottom to top, okay? We write domain and range in two different ways, and we will go back and forth between both of them in this class. So we can write them as inequalities or in interval notation. Interval notation is always going to have an infinity sign. Inequalities are going to have greater than, less than signs, okay? So interval, infinity, inequalities, greater than, less than. A lot of times I will ask you to show both, especially like on your homework and stuff. It's pretty much expected show both ways so that you get really good at it, and then I can kind of specify, oh, just leave it in interval, or oh, just leave it in inequality, or pick whichever one you want. Stuff like that. So if I'm looking at this graph, and let's use this lightsaber. Yes, good. Oh, I like the lightsaber. The lightsaber's like my pencil. Okay, yes? Does that make sense? Okay, so I'm going to figure out my domain. So for my domain, I take my pencil or my lightsaber, and I scan the graph from left to right. Okay? Does that make sense? Scanning from left to right. So I'm scanning. I see the first thing for this function, which is an arrow. What does that arrow represent? Right. It's going on forever and ever and ever in that direction. Okay? And then I keep going, and I'm keeping an eye on my function. I don't see any holes. I don't see any breaks. We're going down, 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 down. Right here, we switch directions, right? So instead of descending, we are now ascending. We're going up or increasing. So we're increasing, and look, another arrow, which it means what? Continuing on forever and ever and ever in a positive direction. Okay, so what this means is in inequality notation, this would be something called all real numbers. All real numbers. Basically, it means everything, but the symbol that we use, it's kind of like that paragraph sign in, English? You know how it has like the double bar? Do you know what I'm talking about? Okay. Some people do, some people don't. But it has two vertical lines for the R, and that means all real numbers, okay? So that is what it looks like in inequality notation. In interval notation, it looks like negative infinity to positive infinity. Okay? When we have an infinity sign, we get parentheses. So you will start to notice that as we go through domain and range, sometimes we will have parentheses, and sometimes we will have something called brackets, which we'll talk about here in a second. Anytime you have an infinity sign, there is a parentheses either in front of it or behind it, closing it off, okay? So that's the domain in inequality and interval notation. Now I'm going to do the range. Now this doesn't work as well, darn. Man, I need a horizontal lightsaber. I can't rotate it? That's fine. Pretend like this is horizontal. Okay? I'm going up, 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 up. And look, the very top of my lightsaber is touching the very first point. Okay? Maybe I'll do an arrow. That's better. Okay, we're going up, 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 up. And we see right here, that is the first point that my graph uses. What is that point on the y values? -2. Okay, so y equals -2 here. So remember, the domain is our x values, the range is our y values, so that's why we're looking at the y values here. Okay? And so, we've got our domain starting at -2, and it's going up, 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 and up, 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 for how long? Forever, right? Going up forever because of those arrows. So how this looks, it doesn't look like all real numbers because it's not all real numbers. My graph never touches anything down here. Okay, it never touches anything down there. So in interval notation, in inequality notation, it's going to be y is greater than or equal to what number? -2. Y is greater than or equal to -2. In interval notation, it's going to be that we start at -2. That's a bracket. And we go to infinity with a parentheses. Okay? The bracket means that 2 is included. It's a closed circle. It's a point that's closed. Okay? If it's not open, it's closed. Okay, you would know if it was an open circle because it would physically be an open circle. But if it's just a solid line, that means everything's closed. Okay, so anything that's closed, circle, or just solid line gets a bracket. Anything that's open circle, which we'll get to later, will not have a bracket. Okay, infinities get parentheses, always. So you'll notice I started with a bracket, but since I ended with an infinity sign, I end with a parentheses. Okay, very specific notation there that will all be worth points on quizzes and tests. Okay, so we are going to do some examples. So remember, domain is my x values, range is my y values. Domain means I go right, left to right or up, bottom to top for domain. Left to right, and then range is good. And I always start at the bottom and go up from there because that's going from least to greatest, which is how you write your interval. So that's why I go from bottom to top. Okay, so we're going to use our lightsaber because we can use it for domain. And we have nothing, 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 dot. Okay, not arrow, dot. Agreed? Okay, this dot is closed, right? Okay, so we keep going, keep going, keep going, keep going, keep going, another dot, okay? But we keep going past that dot, so it's just a point. It's not an ending dot. Keep going, keep going, keep going, arrow, which means forever. Good. Okay, so in inequality, this means x is getting bigger, right? X is greater than or equal to what number? Good, -5, because we started here at -5 for the x values. That was the smallest x value we had. All the other x values got bigger. Okay? The x values started getting bigger from -5. In interval notation, we started at -5. -5 was a closed dot, so it gets a bracket. And then we went towards what? Infinity. And so if it's infinity, it gets a parentheses. Okay, so our domain is x is greater than or equal to -5 or bracket -5, comma, infinity sign, parentheses. We start at -5 and go towards infinity. Okay, now we're going to do the range. So for my range, I'm scanning. The first point I see from the bottom is this point here, which is at where? -1. This is not a great graph to see that, but yeah, y equals -1. Okay, and we go up. We stall. And from here, do we go up anymore? No, we stop. So what is our highest y value? 5. Okay, so this means we're going from, all the y values are between -1 and 5, right? Okay, so our inequality is going to look a little different because it's not just everything's greater than -1, right? Because 7, 8, 10 is not included. So how I remember to do this is I put my y in the middle. Okay, so kind of like where my x is. When we do inequalities for domain or for range, we use a y value because it's y's, not x's, okay? I put my smaller number on the left and my bigger number on the right with some space in the middle. Okay, smaller number on the left, larger number on the right, space in the middle. In between the numbers and y, you're always going to have less than signs when you're doing inequalities with two numbers, okay? Less than. And then we have to determine whether or not they have the equal to sign just based on whether it's closed or open. So we're closed at the bottom, we're closed at the top, so equal to. Okay, so y in the middle, smaller number on the left, bigger number on the right, less than, and then you determine your equal to signs. This is pretty much it. I mean, we're just going to do more practice with it. So for interval notation, what this means is that I start at -1 and I go to +5. Are they both included? -1 and 5. Yes, so do they get a parentheses or a bracket? A bracket. Okay, let's look at number 2. Once again, domain is x values. Range is y values. Okay, I'm going to scan from left to right. Okay, so I'm scanning. The first thing I see is an arrow. What does that mean? Good, continuous. So -infinity. I take that -infinity all the way to this point. Yes? Now here, this is at what? -2? Are there any x values between here? No, there are not. Okay, and so then I pick back up right here at +2. Agreed? Is +2 included? No. Okay, so I pick back up at +2, but it's not included, and then I go here, and then I'm going down, but I'm also going positive, so to +infinity. Agreed? Because it's going to keep going. So with this one, we actually can't even write one inequality because in the middle of our graph, there's a big hole, big break. Okay, so we have to write it in two pieces, okay? So we have our x values that are less than or equal to -2. Would you agree? We have all the x values that are less than or equal to -2 going this way from -2. And then I don't have anything between -2 and +2. But then I have x values that are greater than +2. Are they equal to +2? No, just greater than. So we have two separate inequalities there. Are we following? Okay, so let's talk about what this looks like in interval notation. Interval notation, we're starting at -infinity. Agreed? Okay, so we're going from -infinity to -2, and -2 is included. Right next to it, we're going to write our other interval. Our other interval starts at +2. Is +2 included? then will it get a bracket? It'll get a parentheses, okay? And we go to positive infinity. Okay? So we go from negative infinity to -2, and then from 2 to infinity. Sometimes you will see you'll see this symbol. It looks like a big capital U. So sometimes you will see a U in between for the union. Basically, it says that these two inequalities go together, okay? I always learned with unions, but on like the AP test and stuff like that, they don't use unions anymore. I guess it's obsolete. So I just want to make you aware that you might see how it would look is it would be negative infinity to -2 union 2 to positive infinity. So that's what you might see. Just know that that little symbol in the middle means union, which just means they go together. You don't have to write that. You can just smush them together, okay? But if you see that, that's what that means, okay? All right, now we're going to do, if it will let me erase, now we're going to do the range. So for the range, we're going from the bottom to the top. So starting from the bottom down here, the first thing I see is this arrow. It's going down to what? Negative infinity. Okay, it goes up, 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 and it stalls. Okay, goes sideways. Okay, but this break that was here, this big hole, that hole was in the in the x values from left to right. Do you see how there's not a break in the x or in the y values, like up and down? There would be a break if, let's say, this guy was like up here, like that, and there was like a break right here. Does that make sense? Like as we're scanning up and down, there is no break in the y values, okay? We pick back up here and we keep going up to infinity. Are we following? So there are no breaks, there are no holes in the range. It goes from negative infinity. It does stall out for a little while, but then it keeps going up to positive infinity. So that is going to be all real numbers or negative infinity to positive infinity. Before we move on to the rest of the examples, what does an open circle mean? Not included. Okay, so when you have an open circle, you're going to have a parentheses or like a break in the inequality or something like that, okay? It is not included in our solution. It's like a big hole in the graph, okay? All right, let's look at the next page. The next page just has lots more problems, okay? I want you guys to kind of work through these together. I'm going to walk around and try to help you, okay? And I'm going to intermittently put the answers up so we can check, okay? So I'm going to let you guys work for a few minutes while I fill out the rest of this. And then I will intermittently show you the answers and we'll kind of talk through it. What is number 5 going to be? All real numbers. We have arrows going up, arrows going down, arrows going left, arrows going right, no holes. So all real, negative infinity to positive infinity, negative infinity to positive infinity.